Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And students, today we are going to get into something really very interesting. One of the most interesting part of electrostatics. Not only that, we are going to solve a lot of PYQs in this session. And yes, and this is the kind of like the problems that you can typically expect in your exam, etc. Okay, and students who know me well and good, if not, I'm Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from University of Colorado Boulder, one of the top ranking American university. And I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And I filed 25 patent applications in India and abroad. And guys, if you haven't yet got onto our Telegram channel, do get onto our Telegram channel quickly. So this will help you get timely notifications and updates on daily lectures happening on JEE English. So yes, this link is available in the description box below. First of all, you need to download this Telegram app from Google Play Store or App Store. That is the first and the primary thing that you need to do. So you can check it out on Google Play Store and App Store. And guys, you can just type in as well JEE_English. And with that, you will get all the live updates on whatever is happening on JEE English or any lectures that we conduct even on Unacademy Learning app. So this is that one-stop place. Definitely get onto our Telegram channel. Do not forget to do that. And guys, we have covered units, dimension, and measurements completely from 19th to 22nd September on back-to-back sessions. Not only that, the recent Sunday, that is the last Sunday, we completed a lot of practice problems around them, different kind of model problems around them, and it's a free of cost special class. So do check it out, guys. So do check it out. You don't want to miss it. So do check it out. It's a special class. It was conducted on Unacademy Learning app. Many PYQs, easiest topic, easiest means the easiest topic that you can ever attend, or I mean like even you can prepare for. And not only that, it's easy scoring as well. It does not take any time once you understand the basic concepts around them, and there aren't much any concepts in this topic. And that being said, students, do download an Unacademy Learning app if you don't want, if you don't have one. I'm sorry. But students, the thing is, you know what, once you download the Unacademy Learning app, you'll get timely updates, live timely updates. So how do you do that? You need to just type in Unacademy on your Google Play Store and App Store. You'll be able to find us as the first search result, and you'll just click on the install button. Unacademy is one of the most downloaded learning app across India. And guys, we have the best educators, best content on this platform as well, and many free of cost sessions. So do download it so that you can get live updates on them. And students who are looking for champions tool for your JEE Mains and JEE Advanced preparation, we have one. This is the best kind of program and a platform that you can have for your JEE preparation. So guys, what do I mean by this champions tool? I'm talking about something really very important and interesting for your JEE Mains and JEE Advanced preparation. I'm talking about a structured program. What do I mean by structured program? Yes, I'm talking about an Unacademy subscription platform where you get access to the best educators across the nation along with a structured program. And guys, you get to also attend not only the live interactive sessions, but also get your doubts cleared on time on each and every topic. So that is the awesomeness of this Unacademy subscription. But not only that, it's overall a structured program. So you get to attend, live interactive classes. You will be giving quizzes on those relevant topics. Again, you'll get a doubt clearing session on those relevant topics. So this way, you are completely prepared on each and every topic. So that's the beauty of an Unacademy subscription. It's only one subscription and unlimited access. And guys, all you need to do is click on the extension bar. That will be in the left hand top corner, and then you will choose plus as your option, and then you'll choose IIT JEE as your goal. And with that, you're going to prepare for both JEE Mains and JEE Advanced. So this is an awesome thing that you can have for your JEE Mains and JEE Advanced preparation, and the best thing that you can have for your JEE Mains and JEE Advanced preparation. And yes, guys, you'll just click on this get subscription, and with that, you will get unlimited access during that period. You'll have dedicated programs for your JEE Mains and JEE Advanced preparation, and every single program is going to be a structured program. And we have the best in class technology for your JEE Mains and JEE Advanced preparation, which gives you, the feel of JEE Mains and JEE Advanced preparation, guys. And that being said, the price is also quite reasonable. It's only going to cost you 2,100 per month, which is hardly 70 rupees a day. Right, it's only hardly 70 rupees a day. Sometimes it's 70, sometimes it's even less than 70. And how do you get to this price point? You need to apply Murli Live coupon, and with that you will get the best discount on your subscription purchase. And that is the awesomeness of this subscription as well. It's also quite economical and reasonable. And yes, and you have dedicated programs. This is typically a program for this is for a 24-month subscription. This is typically a program for 9th, 10th and 11th class students, and typically I believe most of you are maybe within this bracket. And guys, this is the time to begin. If you're in 9th and 10th, start early. If you're in 11th, this is the time to start, because we are having dedicated programs for you. And not only that, we also have convenient payment options for you. You can split your payments into multiple parts using our pay in parts feature, which is an in-house feature. And guys, this takes away the burden of all paying all the fee at once. So that is the best thing about Unacademy. And not only that, we also have no cost EMI option as well. So this also takes away the burden of paying all the fee at once, and you get to pay no interest on your EMI. So yes, these are some convenient payment options for you which can take away the burden of paying all the fee at once. And guys, we also have a 12-month subscription program, which is also reasonable. It's only going to cost you less than 2,900 per month. And of course, 24-month program is a little less expensive compared to 12-month program. But 12-month program is also pretty reasonable. It's less than 2,900 per month, only 2,888. So yes, this is also not going to cost much. It's probably like 10 rupees, 11 rupees more per day. And this is the cost that you'd incur traveling to any places. And we have 6,000 plus materials for your JEE preparation. And not only that, right now we have anywhere around 600 plus programs going on. So be sure to enroll soon and get on to our Unacademy subscription platform if you're not yet on it. And guys, you can apply Murli Live coupon to get the best discount. So this is the way you can get the best discount. So do not forget to apply Murli Live coupon during your subscription purchase, and do not miss out the discount. And guys, that being said, launching on 9th October, we have an awesome a program coming up on Unacademy subscription, which is going to take you from the basics until advanced in optics in both wave and ray optics. That is going to be tomorrow sharp at 5:30 p.m. So do not miss out this session. Enroll soon, and if you're already on plus, enroll to the program, and if not, enroll soon and get on to our program. So this is going to be super awesome. The entire program is going to be super structured for your JEE Mains and JEE Advanced preparation. Not only that, students, it's going to be awesome experience for you in terms of your JEE preparation as well as for your learning and understanding of optics. And do remember, optics is the future. It's going to launch tomorrow. It's optics B2A. Be sure to check out. It's going to be a super interesting course. And students, that being said, knowledge has beginning but no end, and today's knowledge is going to be super interesting because it's a combination of not only just electrostatics but also a little bit of mechanics, and typically that is how you can expect your questions in your JEE Mains and JEE Advanced. So that being said, you already remember Coulombs Law. You already know what is Coulombs Law. It states that electrostatic force is proportional to the magnitude of charges and inversely proportional to the square of the distance. And F is equal to K into Q1 Q2 divided by R square, and where K is values 9 into 10 to the power 9 or 8.99 into 10 to the power 9 Newton meter square per Coulomb square, which is the Coulomb's constant for vacuum of free space. And the value of epsilon naught is going to be 8.85 into 10 to the power minus 12 coulombs per Newton meter square. So yes, that being said, you also remember it is a force, it's a vector quantity, it's not a scalar quantity, hence you need to remember to express in terms of vector. And you'll typically, for finding out force on Q2, you'll subtract the position vector of the charge Q2 from wherever you want to find it. Let's say the force applied by charge Q1, then you will subtract the position vector of Q2 from Q1 and actually take a unit vector along the direction, which is going to be R2 minus R1 divided by R1 minus R2. So be sure to remember this and understand this. It's a vector quantity, it's not a scalar quantity. This is typically the magnitude you see. This expresses the proportionality and properties of electrostatic forces, like it is dependent upon medium, and K in a way indicates that it's a strong force, where it is 9 into 10 to the power 9, whereas gravitational force is a weak force, 6.6 into 10 to the power minus 11. So that way you get a gist of electrostatic force and Coulomb's law. But do remember, it's a vector quantity. And similarly, this can be further written down this way: r1 minus r2 whole cube in the denominator, and in the numerator you can have k q1 cubed. It's a simple math, guys, so don't worry about it. You can work it out, but write it down. Do like the video, do share the video, because we are going to get into something really very interesting. And before that, we'll get started on a very simple conceptual JEE Mains problem. Do share the video, students. Do share the video. Do like the video, and you are on JEE English, which is nation's first channel where you get all your content for your JEE preparation from basics until advanced. So do share this channel. Do not forget to do that, and also share the video. Click on that like button, and let's get started with the problem. And it says that an electroscope is given a positive charge, causing its foil leaves to separate. Alright, it's given a positive charge and its foil leaves have gained some positive charge and they are separated. When an object is brought near the plate of electroscope, the foils separate even further. Something like this happened, that you have brought an object near some foil of the electroscope, and you observe that what happened, these leaves further separated. Okay, so you have another a charged or a neutral object that you have brought near it, and this what did it do is exactly near the electroscope. This is just a representation, and these leaves further separated. What does it mean? Probably this is positively hi Yadav, hi Shantal, hi. Absolutely Sandal, absolutely. Hi, very warm welcome, guys, a very warm welcome and good evening. Do share the video, do like the video. We are going to get into hi Aradhya, very good evening, guys. So yes, it should be a positively charged, a simple conceptual question carrying 4 marks, students. Literally 4 marks. Be confident about your concepts. Be very confident about your concepts. That's the most important thing when you're solving any JEE Mains or especially JEE Advanced problem. Hi Sandil, hi students. Yes, that is literally very important, because today's topic you have to be totally confident about what you're doing. Alright, so this was a basic thing around a JEE Mains problem that yesterday I just left you for your understanding what it should be. So be confident. Now let's get into something really very interesting, another Coulombs Law based problem in your JEE Mains. And I'll give you a hint around this kind of problems. So what is happening over here is, okay, let's first of all read the question. There are 3 identical point charges, each of mass m and charge q. Good, really good. That's amazing. So I'll give you a small hint around these kind of problems, and this is one of the most asked model problems in your JEE Mains or even JEE Advanced. Even this year there was a problem, but a little bit related to relative permittivity, I guess, or something like that. Electrostatic force, relative permittivity, buoyancy force. This combination is what you will get, and in today's lecture we'll go through every such model problems. But hanging pendulum with some and a charged pendulum is what you can typically expect, guys. So this is a frequently asked kind of model problem, or let's say the type of problem that you can expect. So typically involves tension. You understood that. So there are 3 identical point charges, each of mass m, and they hang from 3 strings as shown in the given figure. So that's also the reason at least you must have a basic understanding of mechanics, a little bit of mechanics while you're getting into electrostatics. I mean, not necessary for your learning. If you're a 2021 aspirants, yes, it is necessary. But if you're a 2022 aspirant, you can still just listen to the lectures, understand what is being done, because while you're approaching a mechanics, you'll understand the importance of these topics. And typically questions will involve from electrostatics. Generally speaking, they'll involve a little bit of mechanics, basic mechanics, not very complicated mechanics. So yes, so you need to understand the basic concepts, how this works, the simple problem. So it says 3 identical point charges, each of mass m and charge q, hangs from 3 strings, and you can see these 3 strings, they are of length L, and yes, that's all. They are all in equilibrium, and the value of q in terms of m, L, g and theta. Okay. So if you have noticed the option, so given some very complicated option, but there is something that is really common in everything. Okay, pi epsilon naught mgl square sin square theta tan theta pi epsilon naught mg L square sin square tan theta. And if you're totally new to your JEE preparation, good, really good students, really amazing. It's a simple problem. That is really good. You did this problem. It's a little bit, little bit advanced compared to what we solved yesterday. So one thing you need to understand is you need to find something in terms of tan theta, and sin theta should also come in your final result. All right. These are like basic hints you need to pick up, and maybe you don't want to completely solve it, and you want to come to the answer based on these things given in the brackets. I mean, like the 16 by 5 was not given in the brackets in your exam, but something given just around the numbers. You need to play around numbers, and epsilon naught is outside, means this has been expanded by 4 pi epsilon naught. Okay, so let's get into a problem. It's a very easy problem. So first of all, there are two kind of forces you understood. One is the weight itself, which is acting on each of the body. Anyway, this middle body is something that you don't want to analyze. The reason being, it is balanced. So they are all like charges, identical like charges. So the electrostatic force in this direction, due to, let's say, this is 1, this is 2, and this is 3. So in this case, F21 would be in this direction, and F23 would be in this direction. Hence, there would be no force. I mean, like no net force due to electrostatic. There would not be any net electrostatic force on it. There would be a weight, but which is typically balanced by the string. And one more thing is these two objects. So this object and this object would experience the same kind of electrostatic force, and due to which all charges, one due to this charge and the other one due to this charge. If I'm talking about just one, due to this charge and this charge, and both are repulsive. All right, and there would be mg acting along it. First of all, it's an equilibrium, so this is all fine, I guess. So this, let's name this one as 1, this one as let's do a thing. This is 1, this is 2, and this is 3. Okay, now the thing is there would be some tension force, and you will resolve the components as usual in any of the tension problems. So this can be resolved into two components. One is going to be a horizontal component, which is going to balance the electrostatic force, net electrostatic force. So I can call this something like F E net kind of thing. Okay, F E net, and this would be not just due to one charge, but 2 point charges that are hanging over here. And now the thing is, there would be also weight. Mass is m. Identical charges, identical, they have identical masses, everything. It's an identical kind of body. Now this is tension T, and this is going to be T sine theta. Mg, T sine theta is mg. And one important thing by the end of this problem will conclude something. Maybe you want to remember sometimes, not all the time. Maybe something you want to remember, and this is going to be T cos theta, and T cos theta is how much? F E net, right? Simple. Tan theta is what you have to express in terms of, if you observe the options, maybe one among them was, like all of, like A, B, C is not correct, and any among them is not correct, but typically if correct answer do exist, it's going to come in terms of tan theta. So first of all, you will find it out in terms of tan theta. Tan theta is nothing but if I'm going to take ratio of these both, or else you can just even find sin theta, cos theta separately and do it. So it's basically sin theta by cos theta, or T sin theta by cos theta. So TT would get cancelled out. You don't need to write it. But typically speaking, sorry guys, sorry. This is theta. So this is going to be some 90 minus theta, right? This is not going to be theta, but 90 minus theta. So this is 90 minus theta. So this should be sin theta, and this should be cos theta. All right. So that was a small mistake, I guess. Anyway, typically you would observe this result. So this would be theta. Okay, t cos theta is balancing mg. So here also I guess it needs to be changed. This would be cos theta and this would be sin theta. Right? T cos theta and t sin theta. But one thing, if you observed, tension has balanced, and even if you're calculating tan theta just based on force resolution in a balanced condition, it's going to come out as Fe net divided by mg. Alright, this is something that you have, first equation. Now, talking about electrostatic force on this object. Two electrostatic force. One, I'm calling this as 1, this as 2, and this as 3. This is going to be F12, and force applied by 2 on 1, and there is another one which is going to be F13. And now the thing is, what is the distance between them? Right? So we have this theta, which is nothing but we have this theta angle formed by this string 1 with string 2, and there is length L. Alright, this distance would be, so if you take sin theta opposite by hypotenuse, so this is going to be L sin theta, and similarly this one is also going to be L sin theta, and the distance between 1 and 3 is how much? 2L sin theta. Okay, if this is x, this is x, the distance between them is 2x. Alright, so if I'm going to calculate the net electrostatic force, which is going to be both due to charge 2 and also charge 3, both are repulsive. And carefully do notice whether it's repulsive or attractive, that is also very important. And kq by r square, kqq, both are like, all are identical charges. So if I'm talking about, let's do a thing. Okay, I'm talking about these two charges, right now 2 and 1. So it could have been, it would be kq square by r square. In this case, it is L sin theta whole square. And F13, that is going to be 2x. So 2L sin theta, same kq square divided by 2L sin theta whole square. Right? Now the thing is, I'll just write down the value over here, F net, E net. Fe net on this ball, and it's going to be same as this ball, right? And one of the most asked kind of questions in your model problems in your exam. So L sin theta whole square, this whole thing can be taken out as common, and that is going to be 1 plus of 1 by 2 square, which is nothing but 1 by 4. So there would be a 5 by 4. 5 by 4, 1 by 4 by epsilon naught, it should have been 16 by 5. Right? Simple. Alright, anyway, let's do this. So we have this relation. So the thing I was talking about is probably you don't want to always balance the tension forces. In some cases you can typically write down theta and understand that these two forces are related by tan theta. Okay, what do I mean is we derive it, how that comes and everything, but still this is something maybe because if you resolve the components, that is what you're going to get. And every time you don't want to do that, it's sin theta by cos theta. Sin theta is going to be one not adjacent to it but opposite to it. Okay, so it would be Fe net divided by, so you want to directly write it down as Fe by. If you have confusion, do definitely work it out, because these kind of problems are like scoring problems and you don't want to miss them. Okay, if you have any doubts, you want to do it, you may not want to memorize it, but remember it very logically. Okay, Yes, this is going to be FE net divided by mg, right? So this is tan theta, and we derived the value of FE, which was something like kq square by L sine theta whole square, and we had 1 plus 1 by 4, which is nothing but 5 by 4, and I'm going to expand k, like write down the complete value of k, which is going to be kq square by L sine theta whole square into 4 pi epsilon naught into 4 into 5 by 4, right? This is going to give you, like, you have to find out the value of q. So q is going to be under root of L sine theta can be taken out into tan theta into pi epsilon naught 16 by 5. So here itself you should have understood the answer while solving an exam. Hi Roshan, hi, I'm fine. How are you guys? How are you? I hope everyone is doing fine. And let's also hope Shrikant gets better. So yes, that is really that simple, guys. 16 should go on the top, Q is on this side. So these kind of things is something that you want to do in your exams, so you don't spend a lot of time. It's actually, like a 3 minutes problem. So first thing, and don't make the mistake of, so one other important thing in such problems, since you're doing these kind of problems, you're typically, getting used to it, and how to work around these kind of problems. But if not, in the exam, don't forget this 2L sin theta. This is L sin theta. Alright, simple. The answer should be A. Really good, guys. Really good. Alright, let's move on to the next problem, which is also again, and before that, yes, very important concept. So whenever a charge is placed at the center of a symmetrical charge distribution, like let's say this ring over here has charge symmetrically and evenly distributed on it in terms of lambda, then this charge would not experience any force. Net force on this charge is going to be 0. Okay, net force on Q is only at its center, not on its axis. On its axis it will experience a force, students, don't forget it. Okay, we will understand more and more of this as we get into electrical fields, which is even more interesting than Coulombs law. But yeah, net force on Q is 0 given it is placed at the center. Okay, so now like one way to understand this concept is, see, if I take any random let's say dx element over here, and the charge on it is lambda dx, how much ever force this is going to, let's say they are like unlike charges, and this is pulling it, and similarly there would be another such dx on the ring that is going to pull it in the opposite direction. And every such at every such dx there would be another dx. Okay, at every such dx, this is very simple to understand over here. If there is a dx over here, there would be a dx over here. If this is going to pull it this side, this is going to pull it this side. Okay, and similarly, let's say you have something over here dx, and this lambda into dx, the charge is going to be lambda into dx, right? Lambda is in this case it is line charge density, etc. Okay, let's assume this as line charge density. We'll get into more of this during our electric field, but just for your understanding now, you need to understand, because these kind of questions can be there. And on its axis, what I mean by on its axis is, let's say you're placing it somewhere in other than this 2D plane, still at the center, but not at the center, but it has been shifted in axis, then it will experience a force. Okay, so there will be a line, let's say this line charge density, etc., and you're taken a dx over here, lambda into dx. So what I'm saying is, let's say this thing is attracting it, some force F. In its exact opposite direction, there will be a counteracting force of same magnitude. Okay, another dx. This will also pull it in the opposite direction. These both forces will cancel out each other. Similarly, at every single element, this is happening. And even in a disk, let's say this time, it has, like evenly distributed charge on an area, on this complete area, and a small hole has been made or something, and the charge, anyway, it's a point charge, right? And again, even in this case, for every small element, even on the area, there would be a balancing, element that would apply the same kind of force because it's also at the same distance. Okay, if the dx is over here, there will be another such dx. This time, let's say this something like areal charge density, etc., etc. And still, the point is, this will again, let's say this pulls it this way with force F. This guy over here is going to pull with a force F. Same magnitude, opposite direction. That will be true for any other such area. If I'm going to talk about over here, it's easier to understand, I believe. If this pulls with a force F dash, of course it's going to be some F dash. Even there it would have been different. It's an oval, it's not a complete circle, right? And it's a vector. So now there would be, exactly speaking, this would be minus F dash, right? This guy would be applying some minus F dash. Even in speaking in terms of vectors without just the magnitude, so these forces will nullify. Hence, there would not be any such net force on this. Charge Q is going to be 0, and true for even triangle, and true for also if you have something like this, and let's say you just placed it at these corners. You can still walk around them to find out net force is going to be 0. And similarly, for any polygon with charge distributed on it, in this case it's hexagon, so it's going to be 0, and on a square kind of plate with even charge distribution, it's going to be 0. All right, so here again this will apply a force, let's say F, and this will also apply a force. This guy will force F. Okay, it's all charges that we are playing with. Okay. So yes. So let's get into again a JEE Mains problem. So that was the concept, students. So at the center of a symmetrical charge distribution on the same plane, that is anyway the center, there would not be any force on a charge placed at the center. It can be even of an opposite charge. In this case, it's an opposite charge since they are attracting. Let's say even if it's a like charge as well, there would be counteracting repelling forces. Hence, charge would not move, or there would be no net force on it. Any such given geometrical structure. So this, be it hexagon, be it triangle, be it oval or circle, be it ring, etc. Okay, so this pretty intuitive, I guess. So you can understand it by the symmetry divided, and what there will be this half of the ring pulling with some force, this half of the ring pulling with some force. They are going to be in exact opposite. All right, let's get into a very interesting problem. So this is again a JEE Mains problem. Now we are going to begin with something known as combination of mechanics, a little bit of mechanics. Good, Aradhya, good. So yes, this is going to be in combination with mechanics, guys. Most of the problems will be only in combination with mechanics. Right, two particles of masses in the ratio 1:2. Just a moment. So there are two particles, and they have masses 1:2 in the ratio 1:2. And the charges are in the ratio 1:1. The masses in the ratio 1:2 and the charges are in the ratio 1:1, and they are placed at rest in a uniform electric field. Okay, so one thing is they are placed in uniform electric field. We studied this part of it in the beginning. It will experience a force F is equal to QE. totally new to it. Okay, negative charge, it will move opposite to the lines of the electric fields. Positive charge will move along the lines of the electric. All right. Now the thing is, they are released and allowed to move further for same time. The ratio of the kinetic energy finally will be. So guys, does this F is equal to QE? If you have noticed this part, does it involve any anything other than charge and the uniform electric field that is going to influence it? No, right? So both the charges, both the particles, even though they have different masses, will experience same force. If same charge, they will experience same force. Identical charges will experience identical forces in a uniform electric field. Okay, in a uniform electric field. So yes, but how about acceleration, guys? Acceleration, do you think they are going to be the same? Think about it. What do you think acceleration? Acceleration is going to be force by mass. So it's going to be dependent upon mass. It's a very simple problem. This is just a concept that I'm just bringing up. So if you solve it, it's literally like 20-30 seconds problem. That is all it is. And many of you, I believe, are directly guessing from given ratio, etc. It's a simple, very simple problem. So acceleration is going to be different. Okay, so let's do a thing then. So I will call mass 1 to be some 1 unit x and mass 2 to be some unit, right? Good. Yeah, F by Q, F by mass, right? Acceleration is F by mass, right? Now we understood one thing, they are going to experience same force because F is equal to Q into electric field. They are going to experience same force. Force is going to be same. So F1 is equal to F2. We can just write it down as F1 is equal to F2. So M1 is having mass 1x, whereas M2 is having mass 2x. But both Q1 is equal to Q2 is equal to F, since Q1 is equal to Q2 is equal to Q. Right? They are in the ratio of 1:1. They are of they have same charge on them. So now we know force F is the same on them, but I'm saying acceleration is going to be different, right? So what would be the value of A1? A1 would be F by M1, right? And force is same. So if you have noticed a very interesting thing, obviously, right? Heavier the object, applied the same kind of force, would experience lesser acceleration, lesser ability to move. Right? Now, just let's first of all understand these are the two things. First, we need to, this is moving very systematically. Some of you have already understood. They were in the rest and they were released, and hence you have to go by V is equal to U plus AT, which is going to be your first Newton's equation of motion. Okay, right? So V1 is going to be different. U is 0, U1 and U2 is 0, since both the particles were at rest. Okay, hence both will be 0. Acceleration F by M1, we just derived it, right? Same time, T is same, and V2 is going to be F by M2 divided by M into T. Now coming to what has been asked, the ratio of their kinetic energies when they are finally released. Kinetic energy Ke1. Which one is going to have more kinetic energy? Of course, the lighter one is going to have more kinetic energy. So Ke1 half m1 v1 whole square, which is half m1 f, same kind of force, m into t. I'm just writing down t square and this. Okay, just writing down separately. And similarly Ke2 is going to be half m2 v2 whole square, which is going to be half of mass 2 into f by m2 whole square. Okay, t whole square. Now take the ratio of them. If you noticed it carefully, what is Ke1? Ke1 is m1. Sorry, m1 would not be there on the numerator, so m1 would be on the denominator. Okay, f square into t square divided by 2m. At the same time, we are not calculating any t1, t2, etc. And Ke2 would be f square t square divided by 2m2. Right? So Ke1 divided by Ke2 is going to be in the ratio of m2 is to m1. Hi Osho, hi. Right? Simple. I think that we don't have a space over here. I will write it down here. Alright, anyway, I hope you understood it. Next question is super interesting, guys. Very, very conceptual. If you're able to answer the next question, right, then probably you understood every single lecture until now. So if you basically take the ratio, m2 was in the denominator, which will come to the numerator, m was in the denominator for both. They are going to be in the ratio of m2 is to m1, which is nothing but how much is m2? 2x, and the other one is x, so they are going to be in the ratio of 2 is to 1. Right? Anyway, 1 is only given as 2 is to 1. There is 4 is to 1, 1 is to 4 given to confuse you, but it can also be 1 is to 2. Okay, don't get into confusion. Don't move around thinking things. Simply same charges, they will be having identical. No, guys, there are 4 links or 5 links. So one of the students have asked, there is only 1 link for units dimensions. No students. Elaborate detailed lectures were covered on JEE English, and you can check them out. And also, different kind of model problems was and also one-shot lectures, kind of A to Z lectures were covered on Unacademy special app. There should be like 4 lectures, I think, 4 lectures each of around like 3.5 hours, etc. But every single concept is covered. Okay. This so it will be in the ratio of 2 is to 1. Don't get confused whether 1 is to 2 is given. It still should be 2 is to 1. Do remember, force applied on them is same. The lighter particle is going to have more acceleration since the force is the same. And if it's going to have the lighter particle is going to have more acceleration, means final velocity will also be greater. The same kind of time, they will the one with the lighter particle will have more. Like double the kinetic energy in this. Okay. Actually, students, just have a look at the question. At the first instance, hi Vinod, hi. So at the first instance, you should be able to understand what is the concept involved in this question. Okay, at the first instance itself. So make sure you understand the concept. Okay. Anyway, try to guess the answers. Guys. It's really simple. The minimum possible force, magnitude of electrostatic force between 2 point charges separated by 1 meter distance in vacuum. Any guesses, students, what it should be? Simple question, actually very simple question, given that you understand, you attended all the lectures until now. Very simple question, guys. But given that there is a concept involved in it, it's not mathematical. try to guess the answers, students. Try to guess the answers. Try to, try to not just guess the answers, but understand the concept. That is the most important part. Try to understand the concept and try to guess. Try to do the answer in this case. Okay. Simple question, students. Is a very, very simple question. So what is the concept involved in it? So let's first of all forget the options. 9 into 10 to the power 9 Newton. If you have marked this, you have basically misunderstood the concept now. And maybe if you have even marked 1.1, you have misunderstood the concept until now. And probably among this, we'll analyze it. Okay. So yes, so they are separated by 1 meter in vacuum. Okay, that is fine. What is the minimum possible force? So if I'm talking about electrostatic force, so it is going to be between two charges Q1 and Q2. So it's going to be K into Q1 Q2 by R square. Right? Now R is fixed. R is 1 meter. K is fixed. It's in vacuum. Okay, it's in vacuum. So it's 9 into 10 to the power 9. And R is fixed. It's 1 meter whole square. This Q1 into Q2. So F12 is basically 9 into 10 to the power 9. Now you need to analyze something around the charges. What can be the charges? What can be the value of charges such that it is minimum? So these two, the product of these two should be minimum. When is it possible? Think about it very, very carefully. It is only possible if they have a value equal to E. Okay, it is only minimum when Q1 is equal to Q2 is equal to E. What is the concept involved? Quantization of charges. Q is equal to NE. If at all, I have to find Q minimum. What is the value of Q minimum? E. Q into Q, then should be E square. Right? I hope this is clear. Rest is just math. Rest is plain math. Okay. Anyway, you can do it. It's 1.6 into 1.6. So let's do the math as well. I'll take a plain page. So we understood it should be 9 into 10 to the power 9. Since 1 meter, it's on the denominator, that will be 1 square. So not writing it down. Okay. It should be 9 into 10 to the power 9. Now, what is the value of E? It should be E and E. What is the value of E? Minimum charge can be only E. It cannot be E by 2, E by 3 or 2E. Again, it will be greater than E. So that way, what is the value of E? It's approximately 1.602 anyway, only until like 2 decimals have been asked. To 10 to the power minus 19. So it's basically E square, just squaring it. Right. So that is 10 to the power minus 38 plus 9, which is going to give me 9 into 1.6 whole square into 10 to the power minus 38 plus of 9. So this is going to be 9 into 1.6 whole square into 10 to the power minus 29. Right. Now 1.6 into 1.6, 16 square, 2.56. Now how do you do this math? Just a hint for you. To do this math, take it 10 minus 1. Okay, simplest way is nothing but 25.6 minus 2.56. Right? Easiest way to do it. Yeah, I'll update it, guys. I'll update it. Don't worry, Osho, that will be updated. So simply do this thing. This is going to be super easy. This you are going to have a 4, here it's going to be 0. And in an exam, this is something that can help you. Okay, you don't want to do the entire math. These are some basic things that you want to work around. It's basically 2.3 into 10 to the power minus 29. This can be the minimum. This is the minimum least possible electrostatic force at 1 meter in vacuum. Okay, simple. Alright guys, so that is as easy. Yes, your playlist will be updated guys, don't worry about it. So the answer should be B. Alright, let's get into another problem. So now there are two identical point charges having a mass 5 gram. Okay, pretty much we are analyzing typical mechanical mechanics related problem. Even when we get into field guys, there will be many mechanics related problems. So basic mechanics should be clear. Basic mechanics should be clear to solve problems around electrostatics. So that is some issue involved with electrostatic, but at the same time when it is combined with mechanics, problems are going to be easy. There is an advantage as well. So basic electrostatic concepts, or basic any of the electrostatics concepts, and basic mechanics concepts, what you would get. Even in your JEE Advanced, if you noticed one of the questions in JEE Advanced this year, there was a basic problem which had a combination of mechanics and electrostatics, and it was easy. Given that basic things is what you need. These are something that you need to know. So anyway, there are two identical point charges, each having a mass 5 gram and a charge 10 to the power minus 7 coulomb, and in equilibrium on a rough horizontal surface with a separation of 10 centimeter between them. Find the coefficient of friction of the surface. Take G is equal to 10 meters per second. Alright, simple question. Any guesses? If you're working on it, try to get started on it and start solving it, because in a way we are also covering some concepts that you need for your not in mechanics. This is not mechanics. Mechanics you would have more intensive sessions, of course, but a part of mechanics, how you would get in your JEE exam, is covered in this lecture. So do not miss out even a single lecture. Yeah, I'll update it, don't worry. So let's move into this. It's a simple problem. First of all, let's understand. So there are two identical point charges, one over here and the other over here. Now you have a rough horizontal surface, which we may not draw everything like this, but anyway. So the objective to say over here is they have some friction. They have velocity coefficient of friction. So they're like charges, identical point charges. They're like charges. They are going to repel each other with some force. There would be an electrostatic force this way. There would be an electrostatic force this way. Now what has happened? Now there is a friction force that is acting on them. It's not letting them move. Right? Friction force is not letting these particles move. Okay. So what is F mu? Writing down F mu, it's mu into mg. So they are identical. They are going to have same kind of friction force acting on them. And what does they are just at rest is what should have been told anyway. They were just at rest. What can be the minimum coefficient of friction? Right. But anyway, just try to understand the concept. This should have been minimum coefficient of. All right. Now the thing is, how about electrostatic force? Identical charges, K into Q square by R square. What is the value of K? 9 into 10 to the power 9. They are all in vacuum. So how about Q square? Q square is 10 to the power minus 7 Coulomb whole square, right? Divided by R square. How much is R? R is 10 centimeters. Written in meters, it's going to be 0.1 meters. So this again 10 to the power minus 1 whole square. Right? So that is 10 to the power minus 14 plus 9. So this is going to be electrostatic force is going to be 9 into 10 to the power minus 14 plus 9 plus 2. So it's basically 11 minus 14. So it's going to be 9 into 10 to the power minus 3 newtons. So this is your electrostatic force. Now, how much mass is it? It is, we don't know mu yet, we don't know the coefficient of friction, what is the minimum coefficient of friction, and they told us to take 10 meter per second square as the gravitational acceleration. What about the mass? It is 5 grams. Okay, let's do a thing. 5 grams, that is 5 into 10 to the power minus 3 when you convert it into kg into how much is G? 10. This is something like 5 mu into 10 to the power minus, right? The rest is math again. So if you want to find out mu, both are equal. At equilibrium, F mu is equal to Fe, right? I think we'll move on to the next page then. At equilibrium, F mu is equal to Fe. And how much was Fe? Fe was something 9 into 10 to the power minus 3 Newton, and F mu was something like 5 grams. So it is 5 into 10 to the power minus 2, 5 mu into. Okay, so mu should be, so cancel it out. So there would be 10 to the power minus 1 over here, and 5 by 9. So that is going to be 1.8, 1.8, 0.18. Anyway, you already understood the answer. If you just multiplied with 2 on both sides, it should be something like 0.18. Right? Really simple, guys. Really simple. Given that these are like the basic mechanics concepts that you need to apply. This session is going to be about Coulombs Law and all the kind of problems that have been asked. But coming to one of the most kind of popular things that has been asked in JEE Mains, JEE Advanced is simple harmonic motion that gets executed. So let's say we have a test charge over here or a point charge over here, etc. And not necessarily these are like identical charges, but maybe in this case, just for understanding, we have 2 identical charges. And what I did is I'm just displacing this charge a little bit in this direction. So it's at equilibrium. In this case, let's say this is also something like A, and this is also something like A. You displaced it by some x or delta x. Okay. Now what do you think will happen? Once it moves here, the force will be good enough. It will start pushing it in this direction, and this will start pushing it with a greater magnitude. Okay, once this let's do a thing. So I hope this is clear. They are at same distance, in this case identical charges. This and this are identical charges. This can be any kind of point charge. Now I've just moved it a little bit by x. What happens once it comes over here? As soon as this q dash comes over here, this q dash will experience again, like here it was in equilibrium, there was equal forces because it was the same distance there. Now what happened over here? Some x distance is increased from here. So due to this force will reduce the way it pushes in this direction. And now how about the force that is being applied in the opposite direction? Okay, let's say this is by this charge. Okay, now the thing is, as soon as it comes over here, there is this charge, and this charge force is going to also present. Let's call this as Fe2 and this as Fe1. Distance as reduced. And what will happen? This will again move towards until here. Okay, but typically once, let's say, it is not anymore in rest, it has started moving. At some point, Fe1 should be equal to Fe2, but you know what? Now what is happening? Fe1 is less than Fe2. Okay. Now this guy over here is pushing with a greater force than Fe1. More than this guy. Hence, what would happen? It will come to this position. Even if it slightly moves in this position, again it will try to move until X and will come back. So it would execute something like a simple harmonic, something like this. It will go back, it will come back, go back and come. But you know what? This is not the most important thing, like the kind of thing it is going to move. But how do you work around these kind of problems? This is also one of the most asked topics. So typically even torque-based questions will come up in the future. We'll do more around them as well. So now we are also getting quick concept revision for many of them in electrostatics. And yes, in electrostatics, guys, this is something that happens. So let's say in this case, what is it going to be like? Let's analyze this. This is A, this is A. This is displaced by some X. Okay, if this is displaced by some X, let's say in this direction, like what you noticed in the animation, what would happen? Now neatly, to just displaced by some X, this would become A minus X, and the distance between these two charges, and this would become A plus X. So what is the net force on it? One is going to be due to good thing. So let's say due to this guy over here, going to be some q dash by A minus X square. Okay, let's call this as F1. And due to this guy over here, okay, there would be some, it will move until F2, F1 and F2 are balanced, and even if it's again displaced a little bit, it will start oscillating. Right, first of all, let's understand how this works. If I'm going to talk about two quantities, one is going to be F2. Both are in opposite direction. F1 and F2 are in opposite direction. And F1. What is the value of F1? A into Q dash divided by A minus X square. How about F2? F2 is going to be K into Q dash divided by A plus X of whole square. What is the net force? Net force is going to be something like F1 minus F2. It could be F2 minus F1, just talking strictly about the magnitude. Now, it's very important, students, try to carefully understand it. You may get questions around this kind of problems, so that is the reason we are discussing it. So F net, now no more colors, it is F2 minus or F2 minus or F1 minus F2, which is going to be K into Q dash. Since these both are identical, it can be different charges as well. Different charges, different distance displaced, little bit on this side, little bit on that side. This will keep continuing. Okay, and we don't have anything definite on the denominator, which is what we have to work on. Here's this part. This is going to be 1 divided by A minus X whole square divided by A plus X. Right, this is Q dash into A minus X whole square, A plus X whole square minus of A minus X whole square, right, divided by A minus X into A plus X whole square. Can this be written as A minus X square whole square? And if I told you, obviously this will only happen if I have just displaced it such that this displacement X, okay, this displacement X, talking about the displacement X and the relation between A, such that what A is greater than. If not, what would happen? It will go back and may probably just oscillate around the delta X, not much. Asha, yes, if you have a coaching material, you can do it once that chapter and that series around it is over. And yes, DC Pandey is good, but nowadays, yes, probably you won't even move for Harian series. DC Pandey as such is really good, but you want to move forward. Yeah, DC Pandey's book is really good, but the reason today now in JEE Advanced, problems are becoming little bit advanced. So maybe you want to do something even apart from DC Pandey, but anyway, it's an excellent book. First thing, maybe you want to refer to maybe DC Pandey or HC Verma. If time is not a constraint, yes, you can do HC Verma, DC Pandey, Resnick, Halliday, but of course, guys, time is a constraint for you. So do DC Pandey. If you are in CBSE board, good, you'll anyway cover NCRT. If not, you do DC Pandey and maybe take up few advanced problems, solve PYQs, try to understand the kind of problems and then move to any other book. Because in a way you're securing, if you do DC Pandey, you're securing some of the JEE Advanced problem, most of the JEE Mains problem. So typically everything would be clear and conceptually you will be well off. DC Pandey and Resnick Halliday. Else instead of Resnick Halliday, you can also do HC Verma. Beyond that, you need to again go through a lot of problems, and you'll see similar kind of problems that has been that will be solved even by your lecturers, would be from HC Verma. So yes, if your lecturer is not doing HC Verma but doing DC Pandey, yes, you'll go for HC Verma. So that is how you need to move around. You need to plan it within few days. It's good to have multiple books. There is no harm in having multiple books during your JEE preparation. You read it or you don't read it. Sometimes yes, you don't read it, but it's good to have multiple books. Even for referring to a concept that you didn't understand, maybe let's say a concept you didn't understand in DC Pandey, you want to move to HC Verma. And if you don't understand HC Verma, you may want to move to DC Pandey or something like that. But these three books will be completely covering most of the topics, right? Okay. And also one more thing is maintain completeness, very important. If you're doing DC Pandey, maintain completeness. And the beauty of DC Pandey is you'll have a lot of model problems that you can. So yes, guys, I believe this is clear. So this you will write it down as A minus X into A plus X whole square. This is going to be A square minus X whole square. Okay, forget the square part. I'll think about it as A minus X into A minus X into A plus X into A plus X, which is nothing but you take one A minus X and multiply it with A plus X. It's going to be A square minus X square. Again, similarly, you do for one more A minus X into A plus X, which is going to be A square minus X square. A square minus x square into a square minus x square, a square minus x square whole square, right? And if at all your a is greater than x, this can be written as okay. Then you know what? If this is true, then you can write down something like this: a minus x whole square is approximately a square. Okay. So yes, that being said, now what you need to do, you need to find out the net force. Net force, which we calculated to be q dash divided by, I'm writing down a square minus x square as just a square minus like nothing, that is 0 whole square, right? And this is a plus x whole square minus of a minus x whole square, expanded a square plus x square plus 2ax minus of whole thing of a square plus x square minus 2ax. So a square x square would get cancelled, there would be 2ax, again there would be another minus of minus 2ax, which will become plus 2ax. So you would get something like 4q dash into 4ax divided by a to the power 4. So it is going to be k into q dash into 4. One of the a's would get cancelled, it will become a cube. It will be a cube into x. A cube into x. Let's do a thing. We'll keep this x in a different color. I'll tell you why. So this is the net force on it. Okay, this is F into some whole thing to x. So does it represent something like F is equal to some x into k? Yes. If you know this, so Asha, I would suggest maybe going with DC Pandey, Resnick. Depending upon, so what I would suggest is depending upon what kind of problems do your lecturer cover. If you're going to some coaching, what kind of problems are being covered in that? If you're attending on Unacademy from a lecturer, then what kind of book is being referred? If that book should not, and it is fine if it matches, but generally should not match the same kind of, because you'll be spending double the time, and the time is very limited, and nowadays your syllabus are very vast, you have very limited time. Make sure you don't waste any time around same kind of. I would suggest DC Pandey definitely, because more model problems. Even in HCVMA, you have to do all the problems available on the end of every chapter. And in DC Pandey, once you're going through each theory, on the each theory you would have problems. So in a way, you will learn every single concept very systematically. What things should be in the notes? You can keep revising pretty much whatever you learn in the lecture. But guys, notes is important. Notes is very important, especially when you're attending online lectures. Online lectures is the best way to complete, the kind of syllabus you have these days. But the thing is also, given that you have a notes, you can revise it quickly. But at the end of every lecture, when you are noting down notes, you should revise it, and it should be complete. You should be thorough with it. There should be less less necessity to refer the notes, or it should be fewer times. Okay, you cannot go through the notes again and again. You cannot do a chapter again and again. Maybe one short lectures, few revision lectures, some dedicated problems. Yes, time is very limited. Nowadays physics is very vast. And same thing will also go for chemistry. You should try to understand those concepts right away, So in future, what you do is you try to solve the problems from those concepts, not really go through the concepts, because if you don't understand the concept once and if you're doing the problem, there is no feel in it. You are not understanding things. That is one of the major drawbacks. And the other thing is you're not really learning things. In physics, you're supposed to learn things. That will only help you better as you move forward. Okay. So yeah, notes, very important. Write it down, revise it after every single lecture that you're noticing. And if you're reading book and if you want to take down notes, typically, what you'll do is you solve the problems. You read the notes, you can underline them in the book itself. You don't have to again write down the notes if at all necessary. Yes, if something is missing out, because there is a difference, right? When you're preparing for JEE Mains and JEE Advanced, you have to understand every single concept, every way to solve the problem, not just concepts, the way to solve the problem. You're not going to memorize it, you're going to understand it. That there is a difference. If you memorize it, you're preparing for boards. So typically you're preparing for boards. This is by AQ. So you're preparing for boards. But if you're understanding concepts, you're preparing for JEE Mains and JEE Advanced. So try to understand things. Notes are good, but notes are not the must. Alright guys, so this, you can also find out time period 2 pi under root m by k. So it executes a simple harmonic motion. You'll understand few problems around them. It will be clear. So most important thing is, students, note down few things like this. The things that I'm discussing in class, when attending the classes, note down these things. These things are being brought up intentionally so that these kind of model problems are being covered. I mean, in electrostatic, I noticed that the best thing is, do a lot of PYQs and also any model problems in Aryan series, DC Pandey sir's book. So that will sort of give you pretty much you need around JEE Mains and JEE Advanced preparation. But that alone is not going to do everything. You need to understand things. That is the most important thing. You can spend 1 hour just reading that few pages where you don't understand things, and you can similarly spend the same 1 hour understanding things where you don't want to go. You don't have to go through it again. You should not go through it again. If you're doing it after 5 years, 4 years, yes. But at this moment, no. You should not go through your notes. You should not go through it again. Right? You're not going to what do I say? You're not going to memorize it. Then how will you revise such a huge syllabus at the end of every year? Not possible. You have to spend ample amount of time just for completing a syllabus. You'll have to spend a lot of time. So every single concept should be clear. Probably in your revision time, you're just doing model problems, maybe same kind of model problems, something that you missed. So best thing for your revision is something where you made mistake, you want to do it again. Something that you didn't understand will tune your subconscious brain. Memorizing things really won't help you much. At the beginning it will definitely, but later you'll notice this. And especially during your test series, make sure you're attending it honestly. Read your test series, Unacademy special classes, Unacademy live classes, etc. Okay. Let's get into the problem then. Two charges each equal to Q are kept at a distance x is equal to minus a and x is equal to plus a on the x-axis, and a particle of mass m and charge Q is equal to Q naught is equal to Q by 2 is placed at the origin. It's just like this. Let's say this is origin and this is a and this is minus a. Now what has been done, the Q naught is given a small displacement such that y is less than z. So it has been given a small displacement. I think it should have been given properly anyway, plus I think it's plus y. Okay, such that the particle, the force acting on the particle is proportional. What is the force acting on the particle proportional? Typical again mechanics kind of question. Do you think it is going to execute a simple harmonic motion? I don't think so. Let's analyze it. Why? Okay, this is not a simple harmonic motion question. I intentionally brought it. Let's see what happens. So you're displaced by y, which is less than a. Okay. Now it is at a distance a from here. It is at a distance a from here. Let's say your charge is at this point. Okay, right now it's over here, origin, and this is minus a. This position is minus a. This is plus a, and this is. You moved it a little bit along y-axis. What do you think will happen? I think it will accelerate for y. Let's force in this direction. Once it is at this position, force would be in this direction, right? Same kind of force, I mean same magnitude force again, would be acting in this direction, isn't it? Now, does the force cancel out, or does the force bring it back to the mean position? No, it does not. See, this is force along x-axis for this one. That gets cancelled, but along y-axis both will add up with 2Fy. Okay, we can draw a detailed picture after this. But to give you a basic understanding, it won't execute a simple harmonic motion. It will just move along y-axis until some distance. Okay. So now, what has been done? Got a and there is another charge. This is Q, I guess. Q. Yes. And what about this? This is Q by 2. Okay, let's keep it as Q dash. That's not going to change anything. Now let's first of all understand one thing. The force due to this and due to this would be existing, but only the color due to this charge there would be a force along the line joining F, call it as F2. Okay, and this F2 X component, and there would be another such force, and this would have a Y component. Just resolving the forces. Hi Vinod, hi, good, really good. Attend the classes regularly. If possible, take an Unacademy subscription. Be sincere. That is all you need. Really good. And there would be another force along the line joining the charges, which is going to be F1. Okay, I'm calling it as F1. There would be an Fx again in this direction. Cancel out, opposite direction, but Fy would add up. Okay, Fy would add up, they would have been of the same magnitude. First of all, if we just find out Fy, we can just multiply it with 2, right? We'll make a lecture on it, Asha. So your question is, you're in class 11. We'll initially do it for 2021 aspirants, then we'll do it for 2022 aspirants. Right now, be regular to classes, whichever classes you're going, wherever you're attending on Unacademy JEE English or Unacademy subscription platform or your coaching. Be regular, try to understand each and every concept. Don't get confused. Confusion is something that you'll have, nervousness is something that you'll have. Everyone would experience some or the other sort of nervousness. But totally irrelevant, right? Is it relevant that you get nervous about like what is going to happen? No, you need to be you can be a little confused what to do, what not to refer, what to read, because time is limited. That's a good thing. You're thinking about it really good. Now the point is, how do you move about it strategically? So your strategy would be maintain completeness in each topic. Try to solve model problems from Harian series and check kind of your success rate around PYQs. Don't solve PYQs initially. This sessions are, I'm picking up not all the PYQs, only PYQs that have different kind of model problems. But in electrostatics especially, you'll have a lot of model problems. And once you do that, if you're able to solve the PYQs, if you're just attending the session, just doing the concepts, able to solve the PYQs, you're good with it. You're literally good with it. Maybe you want to spend a little bit of 20% of the time solving a little bit of complicated problems. What I mean by complicated problems is which involves in class 11 you will generally not have that kind of opportunity. Try to maintain completeness. Try to maintain completeness in each and every topic. Make sure wherever you're attending classes, each and every topic is being completed. That is utmost important thing. Okay. So first of all, we need to find out Fy. That is going to be absolutely Vinod. Yes, guys, that is the net force. Now, what do we need to do? We have one charge Q over here. Forget rest of the things. Why am I doing this? This is going to be simpler. If you are trying to understand it, I already know it. It's simple. This is A. How much is this? This is Y. I'm just drawing half of it. Okay. And the force would have been something like F1. Okay. We only need the Fy part of it. Fy, how much is this? This is theta. This is also theta. So this is going to be Fy is going to be F dash cos theta. Right? What is cos theta? Adjacent by hypotenuse. How much is your hypotenuse? If this is y, okay, that is a little mathematical problem, but physics is also involved, right? Under root of a square plus y square. Okay. So your cos theta is going to be a divided by f dash of, or f1, I guess this is not f dash, f1 cos theta should be f1 into, we can find out f1 is really simple, under root of a square plus y square, what is f1. Simply f1 is, what is f1? F1 is k into q dash divided by under root of a square plus x square is what you would have, whole square. So you can simply write it down as under y square, y square. So you will simply write it down as, anyway, let's write it down. We'll write it down. So how much is the distance? Under root of a square plus y square. A q dash divided by r square, which is going to be a q dash by a square plus y square. How much is cos theta? Cos theta is going to be, this is a, this is going to be f1 a divided by under root a square plus y square. All right, simple. We know the good, we'll do foundation classes as well, but I think you're over here. Try to attend these classes, try to understand the concepts. Anyway, you're in a good time over here because electrostatics has just begun. It's just like the starter topic, for second year. And first year topics also we are covering. You can attend those lectures. You can come. So this is about cos theta. This is how you derive cos theta. Next is just to substitute f1. And what is the question being asked? The net force acting on it is proportional to. In a way, you understood what is the net force proportional to. If y is very small, you will write it down as a square and y square. Okay, so it's proportional to, I guess, okay, this is x we calculated. This is x we calculated. This fx is not necessary at all. I don't know why did we do this. This fx, so this is going to be the force. Okay, we need to calculate, this was all fx. Fx anyway is cancelled out. We are not worried about fx, we need y. Okay, anyway, f is going to be this. This fy similarly can be written as something like f1 into x, y. I think this is y divided by under root a square plus y square. You will write down a square plus y square as just a square. Similarly, you will have another a square plus y square, which will be again a square. Okay, so it is proportional to just plus y. But what I am saying is this a square plus y square and even this a square plus y square can be written as a square plus y square, since a is greater than y. A square plus y square is approximately a square. So if you write down this entire value, you will see this would nothing be but f y direction, which is going to be total, f net is going to be 2 fy. Okay, so this is going to be f1 into y divided by under root a square plus y square. Okay, fy is proportional to y, fa is proportional to just a. But anyway, it's just cancelled out, so this is irrelevant. You'd have a counteracting force from the other charge. This is irrelevant. So this fy is just going to be f1 into y divided by under root a square plus y square, which is nothing but f sine theta. This is theta. This is how much? f1 sine theta. So this is f1 sine theta, and this is sine theta is going to be y divided by under root a square plus y. Since a is greater than y, you can write down this thing as f1 into y. Similarly, what is f1? F1 is nothing but a q dash under root of a square plus y square whole square. So again, this would nothing be but a square to the power whole square. This would be just a square. Okay, so you have another a. So it's proportional to fy is proportional to y. Hence, even your f net is proportional to just y. Okay, the answer should be a. Okay, let me brief you through this concept again. Anyway, what happens over here is, once this is displaced at certain distance, there are two kinds of forces acting on it. One is going to be this force due to this one, other is going to be due to this one, which is going to be this force. But typically along x-axis, both the forces are of equal magnitude and gets cancelled because they are at a distance only. Anyway, the distance is also same. But along y-axis direction, there would be a force that would be giving it acceleration. Due to both of them, you just multiply it with 2. Typically like how we did it. And how do you find out sine theta? If sine theta would be y divided by under root a square plus y square. That's what I did. Okay, that is going to be fy. f1 into y divided by under root of a square plus y square. So your force is going to be proportional to y. Simple. Alright, let's move on to the next question then. A similar one from based out of your mechanics and electrostatics. So typically many questions you see in your JEE Mains, JEE Advanced, they would be from both a mix of mechanics and electrostatics. So you have two identical charged spheres, okay, suspended from a common point mass by a massless string of length L, and are initially at a distance d less than L. Okay, so what is happening is you have two identical spheres suspended from a common point on a string tension problem at a distance d apart because of the mutual repulsion. Okay, and the charge begin to leak from both spheres at a constant rate. Okay, as a result, the sphere approach each other with a velocity v. So the thing is, then the v varies as a function of distance of how much. You can calculate this part, you can work around it. Given option x to the power 0.5, x to the power x, x to the power minus 0.5, x to the power minus 1. They are asking you what is going to be the velocity in terms of distance, like what is the relation between velocity and distance. As let's say like if it has moved by 1 meter, how is the velocity going to get impacted? Let's first of all understand what is being said. So you have massless string and you have two spheres, identical charged point charges kind of thing, which are being separated. Now the thing is, they need to be balanced, but this of length L, they are separated by a distance t. They are hanged in a massless. Now the thing is, as this value of charge decreases, let's say the Q decreased, what happens to the electrostatic force? Both are leaking, I guess. Okay, both are leaking. The Q is decreasing, they're identical charges, both are leaking. If the Q is decreasing, what will happen to the electrostatic force? To be more aptly stated, as this Q decreases, the electrostatic force also decreases, right? If the electrostatic force decreases, they will move towards each other. They will start moving towards each other. Okay, will start approaching each other. Okay, force of repulsion has reduced. Separation will decrease. Okay. Now the thing is, what is the initial electrostatic force between both of them? It was something like K into both are identical charges, K Q square by R square. In this case, it is D square. Okay. Now D is less than L. Okay, one more thing, one more relation, important relation. Somewhere it will be useful, don't worry. Now let's move on to the next one. The next thing is we need to find out what is this velocity as a function of distance. If this has reduced by some distance x, okay, let's say it has moved by some distance, what is going to be the velocity? All right. So first thing is, we have also in this case, let's just draw one of the balls, not both of them, who is experiencing two kinds of forces. One is mg, other one is electrostatic repulsion. This is kq square by d square initially. Now in the initial condition, everything was balanced. Okay, everything was balanced. Everything was balanced. Right, I'll redraw this part. Two forces on it. Drawing the FBD. String is a massless string. There's a tension T, and this, we remember this part, we did it. If this is theta, this is going to be theta, right? If this is theta, how do you write it down? Tan theta is equal to sin theta by cos theta. What is sin theta proportional to? Sin theta is proportional to kq square by r square. So it should be kq square by d square. Okay. Now we haven't yet substituted d is equal to x. It has as a function of x, not moving by x. So as a function of x. Now divided by 1 by mg. You can do this, we just derived it, right? So typically you get into the habit of writing it down as Fe by, if this is theta, okay, then you can do this. All right. So next thing is, and one way to remember this is what your cos theta component is going to be along the string. And if you remember, just forget, at some inclination, let's assume it was just, a straight without any inclination, it is just straight hanging like this. And mg is going to be all the force. And it is balancing the tension. But after, some displacement, what is happening, like the smooth, like after some angle, there is a force Fe and Fg acting on. And this Fe and Fg have to, due to this repulsion, whatever it can be, Fe or some other force as well. But due to the repulsion, what is happening? This tension is balancing the horizontal component of the tension. Okay. Alright. Horizontal, vertical, simple to remember, Fx by Fy or Tx by Ty. Hence they would give tan theta. Now the thing is, what is tan theta in this case? If this is the distance between them is d, but you need to find out in terms of x. Okay, let's say distance x between the spheres. Okay, now the distance is x. This is going to be x by 2. Right? This is going to be x by 2. What is tan theta then? Tan theta is is going to be x divided by, and theta is going to be, this is x, this is L, this is going to be under root L square minus x by 2 whole square. To be L square minus x by 2 whole square, and whole to the power raised. All right. Anyway, you should be not should be probably doing this, but L is greater than d. Hence it is also greater than x. As the charge is leaking, they are moving towards each other. Since L is greater than d, L is also greater than x. So this can be written as L square. Just L, it can be written just as L. So this is approximately just L. L square under root would be that, it would just be L. So this is going to be x by 2L. The distance between them is x. Half the distance is going to be x by 2. Right? And this is how much? Kq square. Now this is no more d, we are substituting x. Okay, distance between them is x, and this is going to be x square. Alright. Now the thing is, the charges are leaking at constant rate from both these spheres. Okay. So dq by dt is constant. Okay. First of all, we need to derive value of q in terms of x. So it is going to be x cube. I need q, which is going to be q square, is equal to x cube by 2l, x cube into mg by 2kl. Cube. These are all math, but basic concept was this: x cube divided into mg divided by 2kl. Right? That is all you need to know. Now q, how much is q? Q is under root of this, which is going to be mg by 2kl. This is not spring constant kl, but this is just k, Coulomb's constant k. And this is going to be x by 3 by 2. dq by dt is what you would take, right? Because dq by dt is constant. This thing is constant. and this is about left hand side. What about right hand side? You would have something like this thing which is constant anyway, mg divided by 2k, nothing changes, but distance x2 change. Initially it was d, it started reducing to some other value. So it is going to be dx by dt into x to the power 3 by 2, which is going to give you into 3 by 2. Forget all those things. We don't require any more these constant terms. And 3 by 2 minus 1, it's going to be 1 by 2. Right? So these are all constant terms. What we are worried about is only how does it relate to x. And what is this dx by dt? Velocity v. Okay, velocity v. Observe from this term, these are all constants, so just ignore all of them. This is also constant. Charges leaking at a constant rate. So if I just remove that part and just creating a small, over here, so this would look something like this. Dx by dt, which is nothing but velocity, is equal to how much? Some constant a to the power x to the power minus 1 by 2. Right? This would be carried to the left hand side. So this is how the velocity is varying. So velocity is proportional to x to the power minus 0.5. I think everything is given in minus 0.5. Okay, simple problem. Try to go through these problems again and again if you are not getting it. Tan theta thing went wrong, just to correct it. I think we corrected everything, but do remember one thing. Whenever I'm talking about tan theta, how do you, the small thing that you may want to remember is basically tan theta is nothing but fy by fx. In this case, what is fy? It is fy by fx. Yeah, but in this case, this theta is 90 minus theta. It is fx by fy in this case, but generally it is okay. Since theta is shifted in, over here, basically tan 90 minus theta is fy by fx. So in this case, you need to remember what is the vertical component over here. Vertical component is going to be someone P mg. Okay. Yeah, tan theta we're talking about. We're not talking about cot theta. So this is going to be fg divided by fe divided by fg. Okay, maybe something that you want to remember. If you have confusion, just draw the tension thing and you can do it. Okay. I generally like to draw the tension problem quickly. Alternate angles, understand this mg, so, and this is mg, this is going to balance it. So sin theta, cos theta is proportional to mg and sin theta is proportional to fe. Okay, right. All right, we'll deal with rest. There's another concept that needs to come up that generally is asked in exam, which is going to be around relative permittivity. We'll cover that in the next class. It's a very interesting concept. We'll do that. It's super interesting, guys. Super interesting. In fact, there was a JEE Advanced problem this year from the same concept. Maybe you want to try out this concept a little bit, but we'll discuss it in the next class. Do share the video. Do not forget to share the video and try to cover every single concept that has been discussed in the class. Practice yourself again. So do share the video, do like the video, do subscribe and click on the bell notifications to get timely updates. So don't forget to share the video, students. Keep smiling and ignore gossips. That is also very important. Work hard and work smart. Move very strategically, given that if you have less time, yes, move strategically, work smart and hard. Achieve your success, acquire knowledge, but also share it, guys. Sharing is very important. You are sharing the knowledge to someone. So you can discuss, and they'll get access to some amazing lectures, so they need it. So do share it. And guys, if you're not already on our Telegram channel, do get on to our Telegram channel. The link is available in the description box below. All you need to do is just type in JEE_English. And first of all, you need to download Telegram app. If you don't have one, download it from your Google Play Store and App Store. and you can also just search JEE underscore English, and this is the place where you'll get all the live updates on every single lecture happening on JEE English or any lectures that we conduct on Unacademy Learning app. So that's an awesome thing, and we have already completed A to Z of units, dimensions and measurements from 19th to 22nd September on back-to-back daily sessions. But if you have missed it, cover the special class. It's easy, scoring, and less time taking, less time consuming. So that is an awesome thing about it. And guys, it's available on Unacademy Learning app. So for all this different kind of model problems, do check out Unacademy Learning app, and we have detailed lectures, extensive lectures. But model problems are available on the Unacademy Learning app. So download your Unacademy Learning app. First of all, if you want to attend this lecture, all you'll do is you'll search Unacademy on your Google Play Store and App Store. And you'll also get to attend quizzes. So do go and attend these classes. They are free of cost, special classes. So first of all, download your Unacademy Learning app from your Google Play Store and App Store. All you need to do is search Unacademy on your App Store and Play Store, and the first search result is going to be Unacademy Learning app, and then you will just select that link and click on the install button, which is the most downloaded learning app. And guys, we are impacting near about 7 million lives a day, and you are one among them. So don't forget to download Unacademy Learning app. And not only that, guys, if you're looking for a champions tool for your JEE Mains and JEE Advanced preparation, we have one for you which comes with everything that you need for your JEE Mains and JEE Advanced preparation. You'll undergo an intensive and extensive structured program like never before. And guys, every single topic is covered on this platform. I'm talking about Unacademy subscription, and the thing is, you are preparing for test. You're going to attend national level test series. You'll get access to leaderboards and dashboards, which gives you the experience of a competitive environment. Not just because it's going to be some competition you want to compare or something, but you want to understand your standing and where you're going wrong, which kind of topics you're going wrong. And students, it's very important that you attend a lot of tests and you undergo a structured program. Yes, it's a champions tool that we are talking about, and in this champions tool you undergo a champions program. In this champions program, what happens is you undergo a structured program with daily interactive classes with the best educators across the nation, and you also get to clear your doubts from them on time, and you will give dedicated quiz in each and every session. After each and every topic. So it's going to be fully structured. It's a very planned program for your success in JEE Mains and JEE Advanced. And guys, how do you avail this champions tool? All you need to do is click on the left hand top corner extension bar and choose plus as your option, and then you choose IIT JEE as your goal, and then you will get the subscription. And the beauty is, it's one subscription, unlimited access. So what are you waiting for? Avail the subscription soon. And guys, the price is also quite reasonable. If you're going for a 24-month subscription, it's only going to cost you less than 70 rupees a day. So 2,100 per month, less than 70 rupees a day some months. And if you're calculating for the whole year, it's less than 70 rupees a day. And guys, you know what? You can apply Murli Live coupon to get to this price point and the best discount on your subscription purchase. So do not forget to apply the discount coupon. Do not miss out any discounts. And that being said, you can pay in parts. If you do not want to take the burden of paying all the fee at once, you can split your payment into multiple parts using our pay in parts option. And guys, not only that, we have amazing no cost EMI option for you, which also takes away the burden of paying all the fee at once. And this is our in-house feature which has been brought to you for you. And guys, the thing is, yes, these are like the two interesting payment options. We have other traditional payment options as well, but these will take away the burden of paying all the fee at once. And that being said, we also have dedicated program for students who are aspiring to complete the JEE preparation, or who only have 12 months for the JEE, which is going to cost you less than 2,900 per month. Hardly 2,900 per month. It's only 2,888. And how do you get to this price point? You will apply Murli Live coupon to get the best discount on your subscription purchase, any of your subscription purchase. So do not forget to do that. And guys, that being said, we have 6,000 plus programs for your JEE preparation, 600 plus programs that has been hosted just last week. So enroll soon. This is the time to get started. And if you're already on plus, or if you're planning to get this subscription, enroll in the Optics Basics to Advanced course, which is going to launch tomorrow at 5:30 p.m. Don't miss it out. It's going to be a super interesting course where you're going to be taken from the basics until advanced. And not only that, you can be totally new to this topic and attend it. And not only that, we are going to cover both wave optics and ray optics in 60 dedicated sessions on each and every topic. So launching tomorrow, don't miss it out. If you're already on Unacademy Plus, if you're planning to purchase an Unacademy subscription, enroll soon and start attending it. Don't even miss a single class. It's going to be super interesting. And see you in the next class. Take care, stay safe.